Even though wireless networking is hugely popular, wired networking is still used on a large scale in enterprise computing environments. Pictured on the screen, we've got a network switch, into which we have a number of network cables plugged in. Normally, modern Ethernet switches have RJ45 receptacles to plug in the connections. Now there is an indicator light or two for each individual switch port. Generally speaking, a green color or maybe even a blinking green is good because it would signify activity. Generally speaking, switch port indicator lights that are red or amber could be problematic. Refer to the documentation for your specific switch to find out for sure. But if we're not in the wiring closet or the server room looking at this, how will we know there is a problem? Modern switches often have notification configuration settings, so you can be notified when there's some kind of a problem. Now you might say, what could cause this kind of a problem? It could be a number of things. It really depends on what has changed recently, because really wired networks and hardware are pretty resilient to failure once they're set up and working correctly. But sometimes you could have a failing network card that's jabbering too much on the network, or a network card that's configured manually with the wrong speed for the switch port. That kind of configuration could lead to this type of error. If we've got limited network connectivity, there are numerous reasons why that could be happening. One simply could be network congestion. We might have a slow network connection with a lot of dropped connections because the network is simply too busy. That might be because Windows updates are being downloaded to machines, or someone's downloading a large file, or there are just too many machines on the network at the same time. We always want to make sure we do the easy stuff first. That keeps popping up over and over when we talk about troubleshooting, because it's true. Make sure that wired cables are plugged in firmly into the sockets. Then we have to consider things like external interference through EMI, electromagnetic interference. Now this wouldn't be the case with things like fiber optic cabling because that is transmitting wavelengths of light. It's not susceptible to electronic noise. However, if we're using twisted pair copper cables, that most certainly is susceptible to external interference, especially unshielded twisted pair. Now, we would think very carefully when we're troubleshooting this kind of issue. If that were to be a probable cause, we'd have to scope it out. Who is affected? Maybe it's the stations that are near sources of electrical noise, like large pieces of machinery on a factory floor. Then there's more of the software type of troubleshooting, and it wouldn't be specific to a wired network necessarily. Things like using TCP/IP version 4 addresses in the APIPA mode. APIPA stands for Automatic Private IP Addressing. It's a LAN-only IP address that has a 169.254 prefix. This will be assigned automatically by many operating systems in the absence of another IP configuration. It usually means your machine couldn't acquire an IP address from a DHCP centralized configuration, so you're limited to communicating only on the local area network. IPv6 uses what's called a link local address that has an FE80 network address prefix, and this is always present. So unto itself, that is not indicative that there's a problem, because with IPv6, that's used to discover items on the network. It's always there, even when you have a valid configured IPv6 address. So why are we talking about it here? We don't want to look for problems where there are none. We could also end up with IP address conflicts, and usually the operating system will give you a specific message stating that this is the case. Now the solution to this is, of course, to configure a unique IP address on the network. If you're using a centralized DHCP server that has a pool of addresses that gets handed out to devices, then you shouldn't end up with IP address conflicts. Normally you get these when you have people manually configuring IP settings. Now, any of these problems on the network could lead to the inability to access network resources either on the local area network or even on remote networks elsewhere, including the internet. So we might not have access to a shared folder or a printer on the network. And sometimes, if the network is functional with everything else except for these items, it's probably a permissions issue. So then we have to talk to the resource owner to ensure that, in fact, we do have the correct permissions assigned. Now, there are many network troubleshooting commands. We're going to hit some of the most common ones between Windows and Linux environments. In Windows, we can type ipconfig to view IP addressing information. In the Linux world, we can do something similar using the ifconfig command. We'll see how to use a lot of these commands in Windows in a demo shortly. We can also use the ping command if we're trying to get a connection using the ICMP protocol and get a reply back so that we know the target is up and running. In Linux, we can also issue commands like ping 6. And what this does is tries to ping an IPv6 address, where in Linux just ping would ping the IPv4 address. In Windows, the ping command has a command line switch -6 if you want to ping an IPv6 address. But pinging will only work if firewalls allow ICMP traffic, and often on the internet they do not. Now you can also use the trace RT command in Windows, or in Linux trace route, and that will be used to report back for every router that the transmission can get through. So that way you'll know how far down the line you're getting, whereas ping will only tell you that the target is unreachable, when in fact the target might be fine. It might be a router somewhere in between yourself and the target. The NSLOOKUP, or name server lookup command, is used to test DNS name resolution, because we enter friendly names, such as into a web browser address bar, but that's got to be resolved to the correct IP address in order to make a connection. We can also use the dig command to do the same type of thing in Linux as well, to test our name resolution to make sure that it's working properly. If you've already got experience doing network troubleshooting, then you'll be familiar with these and probably more commands.